Polynomial equations may also have irrational roots. In classwork 6-5, we are going to take a look at the irrational root theorem. The irrational root theorem states if the polynomial p of x has rational coefficients and a plus b times the square root of c is a root of the polynomial equation p of x equals 0, where a and b are rational and the square root of c is irrational, then a minus b times the square root of c is also a root of p of x equals 0. Similar to when we have the complex conjugate where we switch the symbol in between, these come in pairs as well. So a plus b times the square root of c, as long as a and b are rational and the square root of c is irrational, means that there should be another at a minus b times the square root of c. Let's take a look and see what that looks like. Okay, an irrational root theorem says that irrational roots come in conjugate pairs. For example, if you know that 1 plus the square root of 2 is a root of x cubed minus x squared minus 3x minus 1 equals 0, then you know that 1 minus the square root of 2 is also a root. Recall that the real numbers are made up of the rational and irrational numbers. You can use the rational root theorem and the irrational root theorem together to find all of the real roots of p of x equals 0. Number 15 on your classwork 6-5 says a polynomial has the zeros shown along with other possible zeros. What is the minimum degree of the polynomial? Also find an additional zero of the polynomial. Because we know that they come in pairs, okay, this 6 plus 3 square root of 3, okay, indicates that there's another. So we have 1, 2, 3, and our possible fourth one would have to be 6 minus the square root of 3. Okay, so our minimum degree would be 4. Our other possible zero, we know we have to have 6 minus the square root of 3. Okay, so our conjugate pair indicates that if we have 6 plus the square root of 3, we have to have 6 minus the square root of 3 as well. Number 16 says a polynomial has the zeros shown along with other possible zeros. What is the minimum, notice it says minimum degree of the polynomial. Okay, so if we have 1, 2, this indicates that we have 3, this would be 4 down here. This is our fifth one, and then the other matching one would be our sixth. The minimum number of degrees we could have would be 6. Our other zero, the one that matches with this, would be 8 minus the square root of 5. And the other one that matches with this conjugate pair would be 3 minus the square root of 3.